Most of the analytics work you will do in radiology informatics will be database analytics. As the name implies, database analytics is the analysis of data sets that are stored in a database. Typical things you will be asked to provide analysis for are procedural volumes, employee productivity, and customer satisfaction. Your analysis will answer questions like, which CT machine is doing the most scans? Which X-ray tech is performing the fewest studies over the last quarter? How long is our turnaround time on ER results? A data set is a collection of data. Typically, it relates to one attribute of an object. Patient age is a data set. Patient sex is another data set. A collection of related data sets is a table. In a patient demographics table, you might have data sets for patient name, date of birth, medical record number, age, and sex, like columns in an Excel sheet. When we talk about a database in terms of business analytics, we're talking about data sets and tables being stored in a database format. There are many database formats and models. Do not confuse this concept with the database server that is part of the PACS network architecture. While it's true the database server stores all the information in PACS, usually in a SQL database, it's not the only database that you will work with. For example, if you're working with a turnaround time report, you may need information from the voice recognition system database. If you're working on a report for contrast usage in MRI, you may need information from the medical administration record or MAR database. My point is, when we talk about searching a database, do not automatically assume that means you're going to go to the database server in PACS and search there. It is very, very unlikely that you will have direct access to a system database. Vendors do not like to have people poking around in their database. If you crash the database, you crash the entire system, and it's not recoverable. When you need database information, you will need to request a database dump. Typically, you don't want, need, or are able to get the entire database. So you will need to specify which tables you want, and the vendor will extract those tables and send you a copy of the information as a CSV file. The picture is what an employee table would look like in a CSV file. If the headers are all in caps with underscores, you can be pretty sure that the information came from a database dump. In business analytics, you will be working with empirical data. Empirical data is simply information that you can see and touch. It's things that you can easily count, like number of ultrasounds done last month or the number of exam reports sent to a particular physician's office. We're only working with data we can measure and quantify. Things like customer surveys and public opinion polls, that's for the marketing department to do, not us. Pareto Analysis, Pareto Principle, Pareto Chart are all named after the Italian economist Vilfredo Pareto, who did a study in 1906 that showed that 80% of the land in Italy was owned by 20% of the population. I wonder if that pissed him off, or maybe he owned some land himself. The Pareto Principle is also called the 80-20 rule. The idea of the Pareto Principle or 80-20 rule is that everything is not equally important. In any system or process, there are a few critical things that drive the large portion of the results. Let's say you want to increase the revenue that the radiology department generates. You could raise the price of all the exams by $1. But if you do some analysis of what exams are performed the most and which ones generate the most revenue, I guarantee you will find a small group of exams, those critical few, and raise the price on only those exams by $2 and then find a way to lower the cost to perform those exams. In the end, you'll generate more revenue than you would by raising the price on all exams. Pareto analysis is a statistical technique in decision-making used for the selection of a limited number of tasks to produce the greatest overall effect. In particular, it's useful when interpreting data. So you never know what the data will tell you, but it's great when you can tell the customer that the analysis identified a few critical things, and if you can improve those few things, you'll get a much better outcome, right? So that's the 20%, the few vital tasks that will drive 80% of the results. If your data fits into that model, you're in great shape and you can show the customer, hey, do these few things, you'll get much better outcomes. Thank you for watching.